All right, so we're going to work on chapter 6, lesson 1, graphing quadratic functions. So what we're going to learn is we're going to learn how to graph quadratic functions. We're going to learn how to find and interpret the maximum and minimum values of a quadratic function. So some vocabulary terms to keep in mind as we work through this, oops, my face, is what is a quadratic function? What's a quadratic term? What's a linear term? What's a constant term? What's a parabola? What's the axisymmetry, the vertex, maximum value, and minimum value? So, how can income from a rock concert be maximized? So, rock music managers handle publicity and other business issues for the artists they manage. One group's manager has found that based on past concerts, the predicted income for a performance is, or P of X, right? Profit for X equals negative 50X squared plus 4000X minus 7500, where X is the price per ticket in dollars. The graph of this quadratic function is shown at the right. Notice that at first, the income increases as price per ticket increases, but as the price continues to increase, the income declines. So, as they increase the price of the ticket, obviously the money they make goes up because the more money that the tickets cost, the more money they make. But at a certain point, if they make their ticket prices too much, then suddenly their income starts to come down. So, one thing that you might say is, well, people are willing to pay money for a concert, but once it gets past a certain point, maybe less people are willing to pay that money, and so you sell less tickets. So, graphing quadratic functions. A quadratic function is described by an equation of the following form. There it is. F of x equals ax squared plus bx plus c, where a cannot equal 0, because if a equals 0, then it's just going to be bx plus c, which makes it a linear function. So this is a quadratic function, right? Quadratic functions typically have an x squared term, or the variable squared. So we call this the quadratic term. So ax squared, the x squared term is the quadratic term. Bx, where it's just the variable with no exponent, that's the linear term. And c is the constant term. And if you recognize c as the constant term, a constant is just when you have a number with no variable. The linear term is similar to if you had like slope-intercept form, like y equals mx plus b. That would be this linear part. So this is the linear term where it's just the variable, no exponent. And the quadratic term is when your exponent has a exponent of your variable has an exponent of 2, right? It's your variable squared. That's the quadratic term. The graph of any quadratic function is called a parabola. So one way to graph a quadratic function is to graph ordered pairs that satisfy the function. So you might have had experience with parabolas already or not. They usually look like a smiley face or a sad face. So that's what we're going to dive into next. So if we were asked to graph a quadratic function, and so they give you a function f of x equals 2x squared minus 8x plus 9, and we could do this by making a table of values. So first we choose integer values for x, right? Things that we could substitute in for x that are really easy to calculate. Then evaluate the function at each value of x, and then graph the resulting coordinate pairs and connect the points with a smooth curve. So here's a table, right? We can make a table pretty easily. So again, these are the x values that we could choose. And again, you could choose any x values. And then this would be the equation or function that you would input it in. And then your output, right? Your y coordinate or f of x, right? And then your coordinate point would be an x and y coordinate or x and f of x. So remember, they're just writing it, since they wrote it in function notation, they have f of x, but typically that's just the y coordinate. So if I selected 0 as a x coordinate, right, as an x value, and if I substituted in, right, for all the x's, once I calculate this out, it will equal 9, right, because 0 squared is 0 times 2 is 0, 8 times 0 is 0, all that stuff, plus 9 is just 9. So that means my coordinate would be at 0, 9. If I choose a x coordinate of 1 and put 1 into the function and calculate it out, that'll give me 3. So I would be at the point 1, 3. And if I chose the value of an x value of 2, input that into the function, and I get an output of 1. So I would have the point 2, 1. You'll input 3, again, inputting 3 in for x into the function, and calculate that out. I would get the output of 3, so I'd have the coordinate 0.33. And finally, you can use the 0.4, input into the function, and you get out 9. And so I would have the 0.49. So now I can take the values from this table, right? These coordinate points, and I can go ahead and put it on a graph. So if you notice, these points are representative of the coordinate points I got in my table. So 0, 9, 1, 3, 2, 1, 3, 3, and 4, 9. So this is that parabola shape that I was talking about. Kind of looks like a smiley face, but obviously it continues to go up forever and ever, up into positive infinity. But this would be a representation of how to graph a quadratic function, right? Take the equation, select some x values, input them into the function, get your outputs, and those are your x and y coordinates, which then you put on a graph, and you make your smooth curve. So all parabolas have an axis of symmetry. If you were to fold a parabola along its axis of symmetry, the portions of the parabola on either side of the line would match. The point at which the axis of symmetry intersects a parabola is called the vertex. The y-intercept of a quadratic function, the equation of the axis of symmetry, and the x-coordinate of the vertex are related to the equation of the function as shown below. So this is a representation of a quadratic function, right? Here's the parabola. So this is the axis of symmetry, right? The line that goes through the parabola that makes it symmetrical on both sides. That point along the axis of symmetry through the middle of the parabola is known as the vertex. And so these are some things that we can identify. If we have a quadratic function in standard form, right? So like ax squared plus bx plus c, the constant term is always your y-intercept. This constant term is where your graph, your parabola, will cross the y-axis. The equation to find the axis of symmetry for any quadratic function is always a vertical line because parabolas always go up and down. So this axis of symmetry can always be found using this equation. So I would write this down. X equals negative b over 2a. And where do you get your b value and a value? From your function in standard form here, right? Your a value is the number in front of the x squared term, and your b value is a number in front of your x term, right? So in your quadratic term, your a, and in your linear term, your b. And so you would input those values in, and you would calculate that out, and that would be whatever vertical line you get. So if you got x equals 3, that means you would have a vertical line at 3. If you got x equals negative 6, then you would have a vertical line at negative 6, and that would indicate where your axis of symmetry is. And then in order to find and that would give you the x coordinate of your vertex as well. So because if you know your axis of symmetry runs through those x values, then you found your x value for your vertex. So knowing the location of the axis of symmetry, the y-intercept and the vertex can help you graph a quadratic function. So let's take a look. So it says, in this example, consider the quadratic function f of x equals x squared plus 9 plus 8x. So they want us to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So we're going to begin by rearranging the terms of the function. So if you notice, it's not quite in the standard form you're used to looking at it. Typically, we would have the quadratic term, and then the linear term, and then the constant. Right now, the constant and the linear term are swapped. So we can rearrange them because it's just adding, right? So we can go ahead and use the commutative property to rearrange that order there. So that will help us. So again, I'm going to take my function they give me and I'm going to rearrange it. So it's going to be 1x squared plus 8x plus 9, right? So now I can see it's a, b, and c, right? Based off our standard form of a quadratic function. So now I know that my a value is 1, my b value is 8, and my c value is 9. So that means I know since my constant is 9, I know it has a y-intercept of 9, right? And now we can use the equation for the axis of symmetry using the a and b values. So let's go ahead and do that. So again, remember the equation for the axis of symmetry is x equals negative b over 2a. So again, I'm going to substitute my value for b and my value for a, and now I can calculate, right? So 2 times 1 is 2, and 8 divided by 2 is 4, so it's going to give me negative 4. So the equation for the axis of symmetry is x equals negative 4. Therefore, the x-coordinate of the vertex also has to be at negative 4. So that's just going to be a vertical line 4 units to the left of the origin. Now we can make a table of values for our parabola. So we're going to choose some x values that are less than negative 4 and some values that are greater than negative 4, just because I know that negative 4 is where my vertex is going to be. So if I choose some points on either side of it, it'll ensure that the points on each side of the axis of symmetry are graphed. So let's take a look. So I pick negative 6, right? So if I put negative 4 here, negative 5, negative 6, and then I can put negative 3, negative 2. So when I input negative 6, my output is negative 3, so I'm at the point negative 6, negative 3. Then negative 5, input it into my function, I get out negative 6, so I have the point negative 5, negative 6. Then there's my negative 4 that I found for my axis of symmetry, so I know that's going to be where my vertex is located. Input that into the function, and I get out negative 7. So now I have the coordinate negative 4, negative 7. Then negative 3. So I have negative 3 into the function, and I get out negative 6. So I have negative 3, negative 6. And finally, negative 2 into the function, right? Calculate it out, and I get out negative 3, which gives me a point of negative 2, negative 3. So notice that the y-coordinates are mirrored on each side. So it makes sense that my vertex, if you notice my vertex, I know that's my vertex because I know that it has an x value of negative 4. If you notice, the 2 points on either side both have a y-coordinate of negative 6. Outside of that, they both have a y-coordinate of negative 3. So that's going to make sure that I have that mirrored or symmetrical parabola on either side. So there's my table. So now I'm just going to take these points and put them on a graph. So this is what it would look like. Right, there's my vertex at negative 4, negative 7. Right, there is negative 5, negative 6. And there's negative 3, negative 6. Negative 5, negative 5, negative 6, negative 3, negative 2, negative 3, and then obviously it keeps going up. And there is my y-axis. So there is my y-intercept, which my y-intercept occurs at 0, 9. And remember, we said that it would happen at that at that constant term of 9, right? That shows me where it crossed my y-intercept. So my parabola is symmetrical on both sides, so I know I did it correctly. If you're ever calculating stuff and you notice that one of your points doesn't quite match up, just recheck your calculations. My guess is it just might be a calculation error. But you can see here that the parabola makes a nice smiley face and it goes up forever and ever. So let's talk about maximum and minimum values. The y-coordinate of the vertex of a quadratic function is the maximum value or minimum value obtained by the function. So if I look at two parabolas, this is known as a positive parabola because it opens up. Well, this vertex down here is its minimum value because it is the lowest y-coordinate that I will ever get, right? It is the lowest that it will ever reach on the coordinate grid. It is its minimum. It does not go any lower. For a negative parabola, right? So that's a parabola that's opening down. Its vertex would be known as a maximum because it is the highest that it reaches. It has the highest y value. It is its maximum point. Okay. So if your a value is positive, that means you're going to get a parabola that opens up. If your a value is negative, that means your parabola is going to open down. Okay, so that's something to keep in mind. You can always tell if something is positive or negative just by looking at the a value, right? Look at the quadratic term, and if it's positive, it opens up. If it's negative, it opens down. So let's consider the function f of x equals x squared minus 4x plus 9. Determine whether the function has a maximum or minimum value, and then state the maximum minimum value of the function. So for this function, since my a value is positive 1, then I know the graph has to open up and the function's going to have a minimum value, right? So it's going to open like a smiley face. That means the vertex is going to be at the bottom. So if I know that I have a minimum value, I can move on to B now. It says state the maximum or minimum value of the function. Since I know it has a minimum, that's the value I'm going to state. So basically what I have to find is I have to find that y coordinate of the vertex, right? Because I know the vertex is a minimum. So I have to find out what is the y value. What is that lowest y value that it's going to have? So the minimum value of the function is the y coordinate of the vertex. And I know the x coordinate of the vertex is going to fall at the axis of symmetry. So remember negative b over 2a, right? So negative b, right? So I know b is negative 4 and a is 1. So when I calculate this out, right, I get this double negative here, which turns to a positive. And then 4 divided by 2 is going to give me 2. So I know that my vertex has an x coordinate of 2. So how do you find the y coordinate? Well, you take your x value, put it in here to find your y value, right? Put it into the function. So here's the function. I'm going to substitute its x value with my x coordinate of my vertex, which is 2. Calculate it out, and I would get that to be equal to 5, right? 2 squared is 4, and then 4 times 2 is 8, right? So 4 minus 8 is negative 4, plus 9 is positive 5. So now I know that the minimum value of the function has to be at is 5, right? Because the vertex is going to occur at 2, 5, right? That's where the vertex is located. So my minimum value is 5. So whenever it asks you to find the maximum or minimum value, it's looking for the y coordinate of the vertex. So there's my graph of what my parabola would look like, right? It obviously opens up because it is positive, so that makes sense. And my vertex is located right here. So then again, my minimum value would be at 5 because that is the lowest that the y values go. It's going to be at 5. When quadratic functions are used to model real-world situations, their maximum or minimum values can have real-world meaning. So when we're asked to find a maximum value, right? So it says fundraising. 400 people came to last year's winter play at Sunnybrook High School. The ticket price was $5. This year, the drama club is hoping to earn enough money to take a trip to a Broadway play. They estimate that for each 50-cent increase in the price, 10 fewer people will attend their play. So A, how much should the tickets cost in order to maximize the income from this year's play? So let's look. The income is the number of tickets multiplied by the price per ticket. So if we let X equal the number of 50-cent price increases, then 5 plus 50 cents times X equals the price per ticket, right? So because we know that the previous price was $5 and we're looking at how much increases of 50 cents we should do. And then we have 400 minus 10x equals the number of tickets sold, because we know that that 400 people came to last year's play, right? And we said that it's going to decrease by 10 people for every 50 cents it goes up, times the number of tickets, right? So we're going to let the I of x equal the income of the function. So the income of the function is equal to the number of tickets sold, right? 400 minus 10x multiplied by the price per ticket, 50 plus 0.50x, right? So this represents the number of tickets that would be sold based off that, and this would represent the price per ticket. So if we multiply these together, that would give us our income. So this is our function that we're going to work with. If we multiply these out, right, these are just two binomials, right? 400 times 5, 400 times 0.5x, negative 10x times 5, and negative 10x times 0.5 x. So when I simplify that out, that gives me 2,000 plus 200x minus 50x minus 5x squared. And then we can combine like terms there, which is 2,000 plus 150x minus 5x squared. So this is our function for our income. So if you notice, it is a quadratic function. So we can go ahead and find out, well, what's going to be the maximum value, right? What's going to be our maximum income based off the number of 50-cent increases. So again, we can rewrite it into standard form. So negative 5x squared plus 150x plus 2,000. So this is my A value, my B value, my C value. So now I can use this information to find my maximum value. So since my A value is negative, I know it's going to open down. So it's going to be like a sad face, right? So it's going to have a maximum value. So I have to go ahead and find out where that vertex is going to be located. So the vertex is going to be located along the axis of symmetry. So I'm going to use my equation for axis of symmetry, right? Negative b over 2a. So I know my b value is 150 and my a value is negative 5. So now we can simplify, right? 2 times negative 5 is negative 10. So it's going to be a negative times a negative is a positive. So 150 divided by 10 is going to be 15. So now I know that my x coordinate for my vertex is going to happen at 15. So it's going to have 15 50-cent increases. So in order to maximize my profit, that's what I need to do. So I'm going to put in my 15 into my x value, right? So let's see. First, we can figure out how much the price of the ticket's going to be. So we put 15 in for x, right? So 15 50-cent increases plus the $5 from last year's play is going to tell us that the price per ticket is going to have to be $12.50. So what is the maximum income the drama club can expect to make? To determine the maximum income, we have to find the y coordinate, right, or the output of the function by evaluating it for x equals 15. So here's our income function right here. So we're going to substitute out x, put 15 in its place. And then we go ahead and evaluate 15 squared times negative 5, and then 150 times 15. And when we calculate that out, it's going to be 3,125. So thus, the maximum income the drama club can make based off those ticket increases is $3,125. All right, thank you guys for watching. Let me know if you guys have any questions.